Alright, let's go ahead and look at multiplication and division of complex numbers. If you have never heard about complex numbers before, I would suggest watching the previous videos and especially watching the video about complex conjugates, because we are going to use that when we get to division in this video. Alright, in the previous video we saw a little about multiplication, so I'm going to do this rather quickly. So if we have a complex number c, and as always, let's make it a plus I times b. So the real part is of course a, and the imaginary part is of course ib. Okay, there we go. Just zoomed out a little. All right, and we also have another complex number. Let's call it w, and as always, it's c plus I times d. All right, let's see what happens if we multiply c by w. Okay, let's just use the right colors. And it's going to be a little different from what we saw in the last video, because in the last video we were so lucky that we multiplied with the complex conjugate, and that made the result purely real. But in this case, the result will be a complex number also. So let's just write it out. We have a plus I times b, and maybe let's just add a header so we know what we're doing here. So this would be the multiplication. There we go. And let's just move it down here. All right, and we multiply this with w, which is c plus id. All right, we saw in the last video, all we really had to do was take a and multiply that with c, and a and multiply that with id. And then at the same time, we also had to do like this, ib times c and ib times id. So if we do that, let's just switch to these colors I used. We would get a times c plus I times AD. But at the same time, we would also get IB times C, so that would be I times BC plus, well, we would get I squared, and then we would have B times D. All right, let's just remember that I squared, that was the whole point of introducing the imaginary number I. It was that I squared that is equal to minus 1. So instead of having I squared here, we just have minus BD. So let's collect the real parts. So that would be AC, and we subtract BD because we had I squared, which gave us a minus 1. And for the imaginary numbers, well, notice that this is multiplied by I, and this is also, or this term is multiplied by I, and this is also multiplied by I. So let's put I outside a parenthesis, but let's just change the color of this real quick so we are consistent. All right, and then we would have I, let's make that in black, and we would have, there we go, AD, and we would add BC to that. So that was simply our imaginary part from here, right? All right, now we are actually done. Let's just write it in some good colors. So we have AC minus BD plus I times, let's make the imaginary part, yeah, let's just make that red, AD plus BC. All right, and that is the result. That's how you multiply complex numbers. All right, there we go. And as I have said before, I wouldn't remember this formula. I would simply remember that all I have to do is multiply these parentheses out, and then I would get the right result, because this is already a pretty long formula, and it makes no sense to remember it when you can simply just multiply the terms and then collect the imaginary part and collect the real parts. So what we see here is that this would be the real part of our product, and this would be the imaginary part of our product CW. All right, let's go ahead and look at division. This is a little more complicated, and we're gonna use the result from the previous videos about how if you multiply a complex number, for example, if we take W and multiply it with its own complex conjugate, then you simply get the real part squared, so that would be C squared, plus the imaginary part squared, and that is D squared. So we're going to use this result, But let's just go ahead and see what happens if we have c and we divide it with the complex number w. All right, this is something we don't really know how to do, because what we have here is a plus ib, and we divide it with, there we go, we divide it with c plus id. We don't know how to treat a complex number when it's down here in the denominator. So what we're gonna do is we're gonna use this trick, and then we're gonna make sure that all the complex numbers are in the numerator, so we can treat it just as we have done before. And how do we do that? Well, we want to multiply with the complex conjugate of w in the denominator, but we can't just do that and still put an equal sign. So what we're gonna do is we're gonna, well, there we go. I'm just gonna go back to writing the symbols now. We're gonna have c and we are dividing it with w. That's exactly the same as before. But as I said, we would like in the denominator to multiply by the complex conjugate of w. But if this equal sign should still be valid, then we also need to multiply by the complex conjugate. That is just like saying you can, if you have 4 and you multiply it with 7 divided with 7, that is simply still 4 because this is just 1. In the same way, this is simply 1. So we're allowed to do this, it wouldn't change anything. But now we can use our trick, because down here in the denominator, we have w multiplied with its complex conjugate. So we can simply write that as c squared plus d squared. So let's go ahead and do that. And at the same time, I'm gonna write c and w out. So we have a plus ib, that's c. And up here, we're gonna multiply by the complex conjugate of w, and that's gonna be c. And remember, when we conjugate a complex number, we simply switch the sign of the imaginary part, sorry. So, and if you can remember this, I would definitely advise you to watch the previous video about complex conjugates. And down here in the denominator, we can use our trick, and we can see, well, that's just c squared plus d squared. Amazing. And what is even more amazing is that up here, all we have now is simple multiplication, and we know just how to do that because we just derived the formula. But as I just said, I would never remember this formula. I would simply do it. So that's what we are going to do too. And I'm just going to do it all in black now. So we're going to multiply a into c and a into id, or minus id. So we're going to get ac minus iad. And for the other part, we're going to have ib times c and ib times minus id. So that's going to give us plus I BC. Then we're gonna have this term that's gonna be I minus I squared BD. But we can go ahead and just remove this I squared because that just gives us a minus 1. So what we're left with is a plus BD. Perfect. And here in the denominator, we still have C squared plus D squared. All right. So let's collect the real part. The real part would be AC. Yeah, the real part would be AC plus BD. And the imaginary part, and it is of course still divided with C squared plus D squared. Whereas the imaginary part, and remember our fraction rules, we can split this up. There's no harm done in that if we wanted to. And in this case, we're just gonna split it up like this and like this. So let's look at these two terms. They both have an I, so let's put it outside a parenthesis. So we're gonna have I multiplied with, well, BC minus AD. And there we go. And that is of course also divided by C squared plus D squared. And there you have it. That's how you divide two complex numbers. And maybe we should, instead of that, let's just make this red so it's clear that this is the imaginary part 2, just like we did in the previous. Then let's just put the I down here, just so it looks nice. There we go. It's exactly the same. Nothing has changed. And there we go. This is the result for how you divide two complex numbers. And once again, I wouldn't go ahead and remember this formula. As you can see, it's pretty ugly and it's not that complicated. All we did was to divide two complex numbers. So what I would remember instead is this step right here. This is what I would think of when I had to divide two complex numbers. I would think, okay, if I have to divide with w, then all I have to do is I have to multiply with the fraction that is w complex conjugate over w complex conjugate, and then just use all my algebraic rules, and then I would get the right result. But that's all for this video. We saw how we multiplied two complex numbers, and we saw how we divided two complex numbers. And I think in the next video we will probably take an example of this, and then we will go ahead and look at the complex plane and complex numbers on polar form. That will be for the next two videos, I think. All right, see you then.